Hello everyone. Today I am here to discuss the basic terminology of the phase rule. After studying this lecture, you shall able to know about the basic terminology of phase rule. Know the phase rule are applicable on the macro system, not micro system. Understand how to calculate phase, component and degree of freedom. Now, let us discuss some basic terminology, that is, what is phase? A phase is defined as any homogeneous and physically distinct part of the system having all physical and chemical properties the same throughout the system. A system may consist of one phase or more than one phase. For example, a system containing only liquid water is one phase system. A system containing liquid water and water vapor is the two-phase system. A system containing liquid water, water vapor and solid ice is the three-phase system. A pure substance, that is solid, liquid or gas made up of one chemical species only is considered as one phase. Some common other examples like a system consisting of water and ice, all the pieces of the ice from one phase and the water another phase. Thus, there are the two phases. A mixture of gases such as helium, hydrogen and argon constitute a single phase since the gases are completely miscible. Each solid makes up a separate phase except in the case of solid solution. For example, many forms of the sulfur can exist together and all are separate phases. Miscible liquids constitute different phases. For example, carbon tetrachloride and water do not mix with each other and form two phases. Liquid may or may not form a single phase. It depends upon their miscibility. Completely miscible liquid constitute one phase system. For example, water and alcohol, benzene and chloroform. Next, what is component? The term component is defined as the least number of independent chemical constituent in terms of which the composition of every phase can be expressed by means of chemical equation. For example, water system has three phases, that is ice, water and water vapor. And the composition of all these phases is expressed in terms of one chemical individual species, that is water. Thus, water system has one component system only. Similarly, the sulfur system has four phases, that is rhombic sulfur, monoclinic sulfur, liquid sulfur and sulfur vapor. And the composition of all these phases are expressed by one chemical individual, that is sulfur. Therefore, sulfur system is one component system. Thus, all the phases in the one component system is expressed by only one chemical individual. A saturated solution of NaCl in contact with excess solid of NaCl has the two phases. The composition of both the phase can be expressed in terms of two chemical individual, NaCl and water. Hence, a saturated solution of NaCl in water in contact with excess solid NaCl in a two-component system. Now, let us consider the another example like decomposition of calcium carbonate, which can be easily represented by this equation. Calcium carbonate are in the solid form, which can be dissociated into calcium oxide and carbon dioxide represents the phases solid and gas. There are the three different molecular species, that is calcium carbonate, calcium oxide and carbon dioxide. But the composition of each phases can express in terms of any two of the species. If any two of the constituents are chosen, the composition of all the phases can be expressed. For example, if CaO, that is calcium oxide, and carbon dioxide are the two constituents, then CaO is equals to CaO plus 0 CO2. CO2 is equals to 0 CaO plus CO2. CaCO3 is equals to CaO plus CO2. If calcium carbonate and carbon dioxide are chosen, then CaO is equals to CaCO3 minus CO2. CaCO3 is equals to CaCO3 plus 0 CO2. CO2 is equals to 0 CaCO3 plus CO2. Thus, the composition of the phases present at the equilibrium can be fixed by the two variables. Therefore, it is the two-component system. Now, let us see the example of dissociation of ammonium chloride. Ammonium chloride, which is in the solid state, has dissociated into the ammonia and HCl. Both are in the gaseous form. So, the ammonium chloride, when heated in a closed vessel, dissociate into the ammonia and HCl gas. The system consists of two phases, that is solid ammonium chloride and the gaseous mixture containing ammonia and HCl. However, the constituents of the mixture are in the same proportion in which they are combined in the solid ammonium chloride. The composition of both the phases therefore be expressed in terms of the same chemical individual, ammonium chloride. Thus, the dissociation of ammonium chloride is the one component system. Now, let us discuss degree of freedom. It is defined as the least number of variable factors of the system which must be specified so that the remaining variables are fixed automatically and the system is completely defined. For example, monovariant or univariant system. For water, which is equals to water vapor system, so the degree of freedom is 1. The system has two variables, pressure and temperature. At definite temperature, the vapor pressure of the water can have only one fixed value. Thus, if the one variable is specified, the other is automatically fixed. Hence, this system has one degree of freedom, that is monovariant or univariant. Now, we will discuss bivariant system. For a pure gas, PV is equals to RT. If pressure and temperature values are specified, there can have be only one definite value of volume, or that the volume is fixed automatically. Thus, it has two degrees of freedom, so the system is bivariant. For trivariant system, a mixture of two or more gases is completely defined only when the pressure, temperature and composition are specified. If pressure and temperature be specified, the third variable, that is composition, may be varied. Since it is necessary to specify three variables to define the system completely, it has 3 degrees. So the system is trivariate. Now let us discuss non-variant system. For ice, water and water vapor system, the degree of freedom is 0. In this system, the three phases coexist at the freezing point of water, since the freezing temperature of water has a definite value. The vapor pressure of water has also a fixed value, since both the variables are already fixed. The system is defined automatically and being no need to specify any variable. Hence, the system is no degree of freedom, means non-variant system. Now, we discuss the phase rule. It is first represented by the Gibbs in 1875. It is a very useful to understand the effect of intensive variables such as temperature, pressure, or concentration on the equilibrium between the phases as well as between the chemical constituents. It is used to deduce the number of degree of freedom, that is F, for a system. Sometimes it is called the variance of the system. So, the phase rule as when the equilibrium between any number of phases is influenced by only temperature, pressure and concentration but not influenced by gravity or electrical or magnetic forces or by surface action, then the number of degree of freedom F of the system is related to the number of components C and the number of phases P by the phase rule equation. That is, F plus P is equals to C plus 2. Now, we will discuss phase rule at constant pressure. Condensed system has no gas phase when their properties are insensitive to the small changes in pressure which occur when fewer variable needs to be specified, which results in the phase rule at constant pressure. F is equals to C minus P plus 2. This is sometimes misleadingly called as condensed phase rule, but it is not applicable to condensed systems, which are subject to a high pressure, for example in geology, since the effect of these pressures can be important. So the rule is useful for some application in material science. Now, let us discuss some advantages of the phase rule. Phase rule is applicable to both chemical and physical equilibria. Phase rule is applicable to macroscopic systems as no information is required regarding molecular or microstructures. We can conveniently classify equilibrium states in terms of phases, components, and degree of freedom. The behavior of the system can be predicted under different conditions. According to phase rule, different systems behave similarly if they have same degree of freedom. Phase rule help in deciding number of a given set of conditions like existence of the equilibrium among variation substances, interconvergence of the substances, or disappearance of some of the substances. Limitations of the phase rule. Phase rule is applicable only for those systems which are equilibrium, but it is much more used for those systems which attain the equilibrium state very slowly. Only 3 degrees of freedom, that is temperature, pressure and components, are allowed to influence the equilibrium systems. Under the same condition of temperature and pressure, all the phases of the system must be present. It considers only the number of phases rather than their amount. Depending upon our presentation, let me discuss some practice questions like define the term phase with suitable example. Define term component with suitable examples. Define the term degree of freedom with suitable examples. Define the term phase rule at constant pressure and explain the one component phase rule with suitable diagram. These are the references. Thank you.